We are going to be talking about simplifying radical expressions in this lesson. This is a long lesson because there's so many different types of problems. So you can pause the video anytime that you want to, or rewind it or whatever. Okay. You can try to simplify the radical as much as you can. If you're multiplying two separate radicals, you multiply the number under the radical, or the radicand, that's what the number is called, with each other, and then the numbers in front of the radical with each other. You cannot have a radical in the denominator in a final answer, so you have to rationalize the denominators. We'll see the examples that I show you for help. Anytime you have an even exponent under a radical, like right here, it's an even exponent under a radical, that becomes an odd exponent when you take it out of the radical. You have to take the absolute value of that variable because principal square roots are never negative. So before I get started working some actual problems, I just wanted to show you some kind of rules of radicals. You multiply the numbers under the radical. So the square root of 5 times the square root of 3 is the square root of 15, and that cannot be simplified. If you have a number in front of the radical, basically what I say is you multiply the two outside numbers, so 2 times 4 is 8, and then you multiply the inside numbers. So in this case, you would multiply the 2 and the 4 and get 8, and then the 5 and the 3 and get 15. All right, so in this first problem, we have simplify the square root of 52. Okay, so we know that 52 is not a perfect square. Now, before you even start, I'm going to tell you, you are not using your calculator for any of this. You are not. If you try to use your calculator, you're going to get a decimal, which is a wrong answer because these need to be exact with no decimals. So this is what you're going to do. You're going to think about a factor of 52 that is a perfect square. And you'll get better with this as time goes on. So 52 is 4 times 13. That's what 52 is. It's 4 times 13. We know that the square root of 4 is 2. So basically, you don't have to do this, but you can. This would be the same thing. So the square root of 4 is 2, and you can't do anything with the 13, so you leave it. Okay? In this next problem, we have the square root of 2 times the square root of 24. You can simplify that first, or you can multiply them together, which is what I like to do with smaller numbers. So there's more than one way to work this out. I'm just letting you know. So 2 times 24 is 48. 48 is 16 times 3. The square root of 16 is 4, and I can't do anything with a 3, so I'll leave that underneath. Now, what I want you to see is right here, I did this problem differently. I could have separated it right there into the square root of 16 times the square root of 3 and gotten that. So either way you do this, it's fine. Now I'm going to do a problem with variables. All right, so the first thing that we want to do is take care of the 45. So 45 is 9 times 5. So I'm going to break that up first. So 45 is 9 times 5. And then I'm just going to rewrite my variables with their exponents. Okay, so what is the square root of 9? We know that's 3, and I can't do anything with the 5, so I leave that underneath. Now, what I want you to see is that the square root, the index number right here is assumed to be a 2 with a square root. It's assumed to be a 2. I know it's not written there, but that's what it's assumed to be. So this is how you do the variables, okay? You say, how many times can 2 go into 4? Well, it can go into it 2 times with none left over. How many times can 2 go into 5? Well, 2 can go into 5 2 times with 1 left over. How many times can 2 go into 6? 3 times with none left over. So look, this is what I'm actually doing, okay? Like with the B's, I'm going, how many times can 2 go into 5? Well, that would be 2 with 1 left over. So this is what's going to go on the outside of the radical. And this is what's going to go on the inside of the radical. So basically your remainders are left inside the radical. That's why I don't have any A's or C's left in, because the 2 goes into 4 and 6 evenly. Now, from the first slide, I said anytime you have an exponent going from an even to an odd exponent, you have to take the absolute value of that, okay? So 4 was even, so we don't have to worry about, well, 4 goes to 2, so that's even to even, that's fine. We don't have to worry about the 5 because it's odd. 6, right here, 6 goes to 3, which is becoming an even to an odd because 6 is even, 3 is an odd. So my final answer is going to be written like this. And that is my final answer. Now, when I'm working with fractions, I cannot have a radical in the denominator in my final answer. So what you're going to do is you're going to have to rationalize. Okay, again, every problem can be worked out several different ways. One of the ways that this one can be worked out is to rationalize the denominator, multiply the numerator and the denominator by whatever is in the denominator, so the square root of 8. When I do that, I'm getting 3 times 8 is 24, and then I have the n. The square root of 8 times the square root of 8 is the square root of 64, which I can simplify. The square root of 64 is just 8. Now, a lot of students want to simplify this right here because 24 and 8 can be divided, but that's not how you do it because you can't simplify an inside number or radicand with an outside number. However, 24 can be simplified, okay? So this is actually not our final answer. The square root of 24, I'm just going to leave this over 8. The square root of 24, I can say 4 times 6, and then that n. We know the square root of 4 is 2. Now, the 2 and the 8 are both outside numbers, so now I can simplify that. So what goes into both 2 and 8? 2 goes into 2 one time, and 2 goes into 8 4 times. So this is actually going to just be the square root of 6n over 4. The 1 is assumed, so you don't have to write it. The reason that this problem is different from the one that we just worked out is because you have a binomial in the denominator with a radical. Okay, so binomial meaning 2 monomials. So we have a subtraction sign in between. Okay, anytime that you have an addition or subtraction sign in between, you're going to have to multiply by its conjugate, which is the same thing but with a different sign. So instead of 4 minus the square root of 5, I'm going to multiply by 4 plus the square root of 5. And I can do that because I'm multiplying by the same thing over itself, which is just like multiplying by 1. Okay, so now what we're going to do is you're going to have to distribute. So we're going to multiply like this. Okay, so 2 times 4 is 8. And 2 times the square root of 5 is just 2 times the square root of 5. Over. Now, what happens when you multiply conjugates? You learned this before in class. What's going to happen is if I distributed like this, okay, if we multiplied the first times the first, and the first times everything in the second, and the second times everything in the second binomial, the two middle terms would cancel out because you would, watch, I'll show you. If you actually distributed this, you would get 16 plus 4 square root of 5 minus 4 square root of 5 minus the square root of 25. What's going to happen is all this middle will cancel out. And so you just get 6 minus, what's the square root of 25? 5. So you just get 11, which is what we get here. Now, to save time, you can just, because you're multiplying conjugates, you can just multiply the first and the last over here. Okay, so you would get that as your final answer. And it's a good answer because it's completely simplified and you don't have any radicals in the denominator. So this is another simplification problem. So 32 is not a perfect square, but it does have a factor that's a perfect square. 32 is 16 times 2. So the square root of 16 is 4. I can't do anything with the 2, so I leave that inside. Okay, so now we get to practice some more with variables. So if there's no index number there, we assume it's a 2. 2 can go into 5 2 times with 1 left over. 2 can go into 2 1 time with none left over. Since the y is going from an even, right here, an even to an odd exponent, we have to take the absolute value of that variable alone. So your final answer would be 4x squared, absolute value of y. You could say to the 1, but it's assumed. And then the square root of 2x. Okay, I want to show you how to do this problem 2 different ways, and then it's your choice which way you do it. I'm fine with either way. Okay, so when you multiply with radicals, you multiply the outside numbers together and the inside numbers together. So 2 times 3, and then 14 times 10. So I'm multiplying the outside numbers together and the inside, which would be 6 times the square root of 140. And then I can break this up into 4 times 35. And so the square root of 4 is 2, so I'm going to bring that on the outside. And then when I bring that number on the outside, I go ahead and I multiply here. So 6 times 2 is 12. And then we still have the square root of 35. And I can't reduce that anymore. Okay, so that's how most people would solve this. I want to show you a different way, and it's your choice. Okay, so we're still going to do the same thing. We're going to say 2 times 3 and 14 times 10. But since 140 is a big number, and you will have bigger numbers than that, to simplify, I just want to show you a little trick. Okay, so let's go ahead and say that 2 times 3 is 6, right? Now break this down. 14 is 2 times 7, and 10 is 2 times 5. Okay, so what I'm going to show you is I'm getting all the numbers, like I'm putting all the 2's together, and you can see I'm kind of putting them in numerical order, 2, 2, 5, 7. So this would be 4 times 5 times 7. We know that 4, the square root of 4 is 2. 5 times 7 is 35. So this would be 12 square root of 35. Again, this way, if you break it up like this with the factors of those numbers, you don't have to think about what a factor of 140 would be. You just have to think about factors of 4. This is another problem that can be worked out 2 different ways. I'll show you one way, and then I'll show you another way. All right, so here you go. If you have a radical over another radical, you can make it one big radical. So if everything is inside a radical, you can put it all together like this. Okay, so then I'm going to simplify that. So 48 divided by 4 is 12. X cubed over x is x squared. And then I have y squared over y cubed, which we know to simplify to just y. Okay, so now instead of having this huge thing, I have what I can separate into 12x squared over y, both in radicals. Now you know that you can't have a radical in the denominator, so we have to multiply top and bottom by the square root of y. So we get 12x squared y over the square root of y times the square root of y is the square root of y squared, which would just be y. Now I'm going to simplify this. So 12 is 4 times 3. The square root of 4 is 2. I can't do anything with the 3, so I'll leave that inside. The square root of x squared is just x, and I can't do anything with the y, so I leave that inside. And again, I'm going from an even to an odd, so I'm going to take the absolute value of that x. The way to do this problem, if you wanted to, is to simplify first. Okay, so the square root of 48 would be 16 times 3. And the square root of 4 is 2. We can't do anything with the x. 2 can go into 3 one time with 1 left over. We can simplify the top too. I'm sorry, the numerator. All right, so the square root of 16 is 4. I can't do anything with the 3, so I leave it. 2 can go into 3 one time with 1 left over, and 2 can go into 2 one time with none left over. And if I put that over this, I can simplify. 2 can go into 4 two times. The y's would cancel out. Okay, so I would just get 2x square root of 3x over the square root of xy. Now I can multiply top and bottom by the square root of xy. When I do that, I would get 2x, and then I multiply all the inside stuff. So 3x times x would be x squared over y, and then I would just have x and y on the bottom. Okay, now, all right, I'm going to simplify the numerator again. 2x. I can't do anything with the 3. 2 can go into 2 one time with none left over, and I can't do anything with the y. Now, I can simplify, and one of these x's can cross out. And again, my final answer would be 2x square root of 3y over y. And then you take the absolute value of this x because you're going from a square to 1. I think this way, the first way, is a whole lot easier to make it one big fraction instead of trying to simplify one at a time, but it's up to you. Here we have another fraction with conjugate, well, with a binomial in the bottom that we have to multiply by its conjugate. So I'm going to multiply the numerator and the denominator by 4 minus the square root of 2, because that's a conjugate of 4 plus the square root of 2. So I'm going to distribute. 3 times 4 is 12. 3 times the square root of 2 is 3 times the square root of 2. We know that when we multiply conjugates, the two inner terms cancel each other out, so I can just multiply 4 times 4, and the square root of 2 times the negative square root of 2, which would be negative square root of 4. So I would get 12 minus 3 square root of 2 over 16 minus 2, which is going to simplify to give us 12 minus 3 square root of 2 over 14. And I can't do anything with that. I know a lot of students think that I should simplify the 12 and the 14. I can't, because unless every coefficient here, if all 3 coefficients outside of the radical were divisible by 2, I could do that. But since this 3 is not, I can't. It has to be all or none. The last problem we're going to do is just another simplification problem. So 60 can be broken down into 4 times 15 because 4 is a perfect square. So the square root of 4 is 2. I can't do anything with the 15, so I leave that inside the radical. Again, an index of 2, so 2 can go into 3 one time with 1 left over. 2 can go into 4 2 times with none left over, and 2 cannot go into 1, so I leave the z under the radical. Okay, let's check. 3 is odd, so that's fine. 4 is even, but it's going to a 2. That's also even. and you don't have to worry about your z's. So this is your final answer.